Guys, what's the crack? So this one is a video about beta minus decay. So this is something you'll learn in year 12 when you first do those particle interactions, and you also will do it again in year 13. We're doing nuclear decay. So we're doing this in nuclear decay right now in our online classes. So if you want to join our online classes, you can always sign up at the MyEdSpace website, and the link's in the descriptions. But it's really important that you understand this, okay? So beta minus decay, how do we figure out what to do? So decay, obviously, is the beta minus, that fast moving electron is getting emitted from the nucleus. So that's what's coming out, one of our electrons. So now I figure out what changed to give me one of these electrons. So how I would do it first is look at my charge. So my electron has got a charge of -1, right? So now I need to think, how do I conserve charge? Now the only thing I can add, because remember it's in a nucleus we have our protons and our neutrons, okay? Now I need you to figure out, if I put a proton here with charge +1, they're never going to balance nicely. So the proton clearly can't go on this side of the equation. So my proton has to go on the other side of my equation. So my proton has to go here because it's going to be a +1 charge. So overall, they're going to give me a 0 charge. So that makes sense then why my neutron's over here, because my neutron's got a charge of 0. So we can see our charges now are balanced on both sides of equations. So what happened inside the nucleus in beta minus decay was a neutron changed into a proton. So it's a nucleus that's got too many neutrons. Now we need to finish off our equation. So what we're going to do now is we're going to balance our lepton number. Okay? So a neutron is not a lepton. A proton is not a lepton. An electron is a real lepton, so we get a lepton number of +1. So in order to balance the lepton number, clearly I need to have a lepton number of -1 on this side. But I know its charge has to be 0 because I've already just balanced my charge. So thinking, what lepton has no charges? I know the leptons with no charges are my neutrinos, but it needs to have a lepton number of -1, so it needs to be an antiparticle. So it's going to be my anti-neutrino. So that's where we figure out what's left. And just make sure everyone's happy, if we also looked at our baryon number, a neutron is a baryon, so baryon number +1. A proton is a baryon number +1. An electron is not a baryon. A neutrino, an antineutrino, is not a baryon. So again, our baryon number has been conserved because we have +1 baryon number on this side. We also have +1 number of baryon number on this side, right? It doesn't mean they have to both be 0 on each side. It means whatever the number is on this side, it has to be the same as the numbers on this side. So hopefully you find this helpful. Please check out my resources. We have loads of content, loads more examples, loads of past paper questions for you there.